Okay, so a little help here. We're trying to find column space for an AX equals, for this A here, right? So we have some general AX equals B problem we set up. This is known, right? So we're given a bunch of numbers here. I'm not going to tell you what they are, but we've been given a bunch of numbers here. We leave B, and this is a 3 by 4. This is a 3 by 1. And B we started off with as B1, B2, B3. This is one of our ways of finding column space. We say, all right, let's find all the B's for which AX equals B works. Right? All the B's that the columns of A can make. So, row reduction occurs, some magic occurs. That's not part of this question. And we get to the start of the question, which is, given this reduced row echelon form of A, which we're going to write as R sub A, so two of the rows just disappeared, the zeros, so it had to be in the first place that they were multiples of the first one. Anyway, that's another piece. And whatever happened to, we start with B and we start to move the B1 and B2, B3 characters around, we end up with this new vector D. So here's our equation, or here's our problem now. This is R A X equals D, right? So again, a 3 by 1. This is a 4 by 1, and this is a 3 by 4. So things match up. And so we know this character, we know D in terms of the B's. And then to find column space, we have to look at the conditions on the B's, and we can see that there will be conditions. So if we take this out and put it back into equations, we have some line across the top, so it's x1 minus 2x2 plus 4x3 minus x4 equals B1. That's fine. There's nothing special about this. We can choose whatever B1 is. We should be able to solve this. So this we can ignore this, right? So basically, the story is it's not 0 on the left, so that's fine. But these two equations, the second and third rows, give us conditions on the B's. Okay, so we need to accommodate them. And if we look at this, we can see, well, this is some linear combination of B1, B2. And there's really a 0 times B3 here. Same thing here, and they equal 0. So if we turn this around, let's turn it around, B1 plus 4B2. So this is like inception, right? Problems with inside problems. This is equal to 0. Should we be thrilled about that? Because everyone understood inception. Very, very simple, transparent film. So we're going to just turn it around. So now we have B1, B2, B3. So this is instead of x's. A little bit funny, and that in matrix form is minus 1 plus, and there's a 4 here, a 0 here, minus 6, 25, and 2, multiplying the vector b1, b2, b3 equals 0, 0. So a 2 by 1, 3 by 1, right? There are 3 unknowns, and a 2 by 3. 2 equations, 3 unknowns. So we're looking at, this is a null space problem. Null space problem, right? Looks like AX equals 0, but of course now we have a B, but it's this sort of thing. So what we're trying to find, which combinations of the columns of A give us 0. And when we've done that, we will have the column space of A. So find the null space for this matrix. So the null space of this matrix minus 1, 4, 0, which is a little hard to get to, right? We had to 25, 2. The null space of this one is equal to the column space of A, original problem. So think about this, it's good, couple of layers, not 4 or however many there were in Inception.